Okay, hi everyone. We're going to work on question number 3 now for our final review. So the question is blah, blah, blah. Now the thing is if you don't know what the question is asking for, you're going to have to spend 30 seconds reading this stupid question. But you can see that this is a function, and we're going to estimate the limit. Sure. So on the right side, find the limit as x approaches 5 from the left side. You guys all see that? It's from the left side. So if we're looking from the left side here, here's our 5. Here's our 5, right? That's our 5. From the left side, the limit looks like it's going to be 6. That's what the graph looks like. It looks like it's going to be 6. Okay. And then if we, I forgot I need to, we can hit 6 there. Sure, high 6. Oops. 6, enter. Excellent. Yes, I know. And the next question is, what is that going to be on the right side? The right side, if you look at the graph, it's going to be 3. All right, let's put 3 there. I'm just going to hit enter. Check answer, yay. And then, is there a limit at all? Remember, if the left side and right side do not agree, the left side says 6, the right side says 3, they do not exist. So the limit does not exist. And this is just a remember, do you remember how to do this? And what is the actual value at 5? The actual value 5 is the dot at 4. And that was just a, do you remember how to do this? Oh, does f of negative 5 exist? So, whatever, we did this already. Oh no, this is a new one. So does the value at negative 5 exist? The function at negative 5 is way over here on the left-hand side, and it's hollow or solid. It's solid. See, that's solid. So that's going to be, sorry, you guys can't even see it. It is solid here at negative 5, so it does exist. Does the, what's the limit as x approaches negative 5 on my left side? So here's negative 5. Oh, sorry, on my right side, that looks like it's going to be 2. That does exist, yes, because there's a value there. Does the limit equal to the function value? Yeah, it's hollow and it's solid, yes. We should get to the harder questions, actually. And is f continuous at negative 5? Is f continuous at negative 5? I mean, I would say it is continuous, but maybe not. Maybe it doesn't exist on the left side. Let's check. Oh, they want to say it's continuous because it's solid? Oh, that's an awkward one always. All right. The question is, find the point of discontinuity, and B is the discontinuity removable or not removable? All right. Let's just go ahead and answer the question. So if I plugged in, okay, this is a piecewise function where the graph does not exist at negative 3. So let's go ahead and mark this up. So we know what this graph looks like. That's a parabola. At 1, 2, 3, you don't have to graph it. But at 3, it's a downward facing parabola. Oops, sorry, wrong one. Sorry, downward facing parabola at 3. And then at positive 3, 1, 2, 3, whatever that is, 3 squared is 9, 9 is negative 6, so we're actually down here, negative 6. It doesn't exist. Okay?
It does or it
It
doesn't?
doesn't exist. It doesn't exist there. Because if I plugged in 3 into 3 minus x squared, the value should be f at, darn it, I can't write f because f doesn't exist there. So if I write 3 minus 3 squared, that's negative 6. And we're saying the graph does not exist there. Oh my goodness. The graph does not exist there. And the question is, oh, the second part of it is saying that, hey, well, fine, I get it, it does exist there, but can you plug up the hole and at 3, graph negative 3 instead? So did my negative 3 plug up the hole that was missing? No, there's still a hole there.
Mr. Cole.
Yes.
So is the point of discontinuity always that one that they show like is not equal to?
Yes, that's the point that doesn't work. They want you to just skip out on that moment. It's like, oh, sorry, I was in the bathroom. And then they're trying to cover it up with this next point. Try to fill in the gap with that second point. Now, does that second point fill in the gap? Nope, it missed. And So the term removable refers to if it's missing at that one exact point. Yes, it's removable because it's just this one point. If I got a Sharpie and I filled it in, yeah, see, it's perfectly fine. We're good. And that's what removable means. A graph that does this is not removable, okay? Oh, look, I just need a little dot to fill in the gap. That is not removable.
So pretty much for this problem, the answer was in the question.
Yeah. They just
Okay.
want you to read the question and understand the situation. And some of the AP questions on the AP test are that. They want you to want to check if you actually know your calculus. Not just know how to solve it, but do you know your calculus? Do you understand what's going on? The question here is sketch the possible graph of the function that has the stated property. So f at -7 exists, as well as the limit does not exist, okay? So I'm not going to use the graphs that they gave us here, but I'm going to go ahead and talk about it in a sense of f does exist, but the limit does not exist. Okay, so this is an overall limit, so from the left and the right side. So if I'm drawing a graph, we can say this is at 7, okay? So the f of 7 does exist. Yes, we see a point, but does a limit exist as x gets closer to 7 here? No, the limit does not exist. Now, when would a limit exist and the value not be, would also exist? What if they both exist but they weren't the same? If I give you a graph that looks like this, put a hole there, and put it up here. I call this 7. Yes, f of 7 does exist. It's right here. But the limit, and the limit as we approach 7, also exist, but they are not the same. F of 7 is not equal to the limit as x approaches 7. So the value does exist, yes. The limit does exist, yes. Okay, because the left side and the right side both agree. But they are not the same. Now, if they are not the same, this is not continuous. Okay. So this is not continuous. So we have a lot of descriptions of what's going on here. So you guys can figure that out, hopefully. Our next question here is find the average rate of change. If you guys remember what the average rate of change is, it is not the derivative. The derivative is instantaneous. Average is overall. And whenever they give you an average rate, they always give you a boundary. So here's our boundary. We're looking at our left and right side here. So our left and right side. So we're going to plug in it's the same equation as slope. So average is f of b minus f of a over b minus a. Okay, that's our average. So we're going to plug in the square root of 3 times 1 plus 1 minus the square root of 3 times 0 plus 1 all over 1 minus 0. Okay, so that's going to be 3 plus 1 is 4, square root of 4 is 2. 0 plus 1 is 1 over 1, which is 1 in this case. So please be careful when we're looking at rate. Rate is a great way to realize this is a change. But what type of change do they want? They want average. Average is when we take this case here. Right. Question number 8. This is just find the derivative. Now, if you remember this is just taking the derivative. This formula is f of b minus, f of our new version minus our old version over h, the difference between the two. This is just taking the derivative and then plugging in 6. That's what this is. Take the derivative and plug in 6. I'll do it quickly. Let's see if we end up with the same answer, okay? So we say f of limit h goes to 0 of 1 over a plus h minus 1 over a all over h. Common denominator on top is 2 minus a plus, darn it. Yeah, 2 minus a, what am I doing? A multiply a minus a plus h over a plus h all over h. We end up limit h goes to 0. On top, this is negative a, negative h. The a's cancel out, leaving me negative h over a plus h. And then we multiply by the reciprocal of h over 1 is 1 over h. These divide out, yay, is equal to negative 1 over a plus h. Okay, and then now we plug in the limit as h goes to 0. If I plug in 0 here, high 0, that's okay to plug in 0 now. Negative 1 over a squared. And then we can plug in the 6. This is negative 1 over 36. Oh my gosh, let's go. But instead, if you're smart enough to realize they just wanted the derivative, can we just take the derivative of 1 over x? X of negative 1 is negative x of negative 2. Negative 1 over x squared. Plug in the 6 is negative 1 over 36.
Mr. Ko, why do we even learn the AH thing?
Is because what is a derivative?
Oh, it's like explaining it?
Yes. And
Okay.
what a derivative? It's slope. That's what a derivative. It's straight slope. And I'm trying to find out what the slope is of 2 points that were 0 spaces away from each other, infinitesimally small. And when we do that, we end up with this guy here. And it turns out, look, if we start off with 1 over x, the slope, the derivative is negative 1 over x squared, which is our power rule. So it gives us the reason why power rule works. Instead of just always bring down the exponent, it's always going to work. If I bring down the exponent, that's the answer to the universe. Right? That's the reason why. And if I do this for any power rule equation, it'll always just give us the power rule, which is kind of cool. Same thing here. If you realize that this is just the definition of a derivative, right? See, this they even tell you f prime. Just take the derivative, plug in a. Oh, take a look here, folks. They literally told you take the derivative. They say the derivative is f prime, plug in a. Just take the derivative and plug in a. They told you that right here. What's f prime? Oh, f prime's a derivative. So take the freaking derivative. Save yourself some time. Okay, quotient rule. I don't think you need me to do quotient rule, right? Anyone need me to do quotient rule?
Wait, Mr. Ko, I have a question about the
Yes.
last one.
Yeah, sure. Let's go back.
What I did it the long way where I plugged everything in. What's
Yep.
the shorter way?
Just take the derivative.
So you take the derivative of that and plug in a for x?
Yeah, look. Sorry. I should
You're
say look,
kidding
but then
me.
it doesn't. Look. What? Look. Oh, darn it. Come here. Get back here. Ah, darn it. Let me go ahead and mark it up so I can be a real jerk about this. They told us, we know what this means. That's the derivative, right? Plug in a.
Yeah.
Definition. So if you give me f, why don't I just take the derivative and plug in a?
Mr. Ko, I spent like 10 minutes doing that whole problem.
Well, that's the point. We learned that this difference quotient is our reason why the derivative works. It's the reason why it works. So, yeah. And this is also why we learned how to do this in pre-calc.
So the derivative is just 2x and then you plug in.
Yeah, it is.
Great.
But that's why, like, after we learn how to do derivatives the long way, we're like, Michiko, why didn't you just tell us the power rule before? And because if I just tell you random crap to do without telling you why it's true, I just sound like your parent then. Because I said so.
Honestly, I might would have rather you said that.
Yeah. Okay, so this next problem here, anyone need me to do a quotient rule? Anyone at all? If not, I'm gonna move on, okay? Same thing. This could be quotient rule, but we talked about these problems before. I would maybe multiply it first and then divide by x cubed. Okay, I think that would be easier. Even though it might take a little bit more work, that's what I would have done, because it's no brain power. For me to multiply the top is no brain power. That's x cubed plus 5x squared plus 25x. Then negative 5 is negative 5x squared minus 25x minus 125. Oh my gosh, I should realize that's the difference of two cubes. Mr. Cole, you're an idiot. Okay. Then we can divide this if you want. I'd rather just divide this right now. That's 1 minus 125 x to negative 3. That'll save me some time. The derivative of 1 is 0, and the derivative of this guy is 3 x to the negative 4. Oh, and don't forget to multiply by 125 negative. And that's how I really got that.
You mean negative 3x to the negative 4.
Yes, when I multiply them together, you end up with a 375. Oh, dang it, negative, thank you. Yes, that's what I meant. Yeah, perfect. Thanks for catching that. Of course, Mr. Ko didn't forget his negative sign. Now again, instead of complaining and saying, oh my gosh, I just multiplied it to make the problem easier. From here, you could have done quotient rule, but I prefer not to. And this became actually easier. I don't like negative exponents. I don't like to do a lot of work. Okay, this one looks pretty ugly. I'm going to go through this quickly because I know some people might need the help. Sorry guys, I'm going to go all the way to the bell because I want to make sure I can get as many problems as I can. But if you guys have to leave, you guys can leave. I know Dove is driving around.
I'm just headed home. I'm sorry.
No, we're cool. I'm playing with you, man. I'm just playing with you.
And I didn't. The mic went on accident. I didn't mean to distract anyone.
No, that's
my
fine.
bad.
It's okay. It was fun.
I'm still paying attention though. You know, I'm
Yeah.
visualizing.
Right, I got it. Multitasking while driving. We never end up with accidents that way. I play Pokemon Go while I drive. See, no problem.
Mr. Carr, there's going to be a cop in your class soon. For
Ooh.
him being on his phone, he's going to get a ticket.
Uh-oh. I mean, I told him not to, right?
Mr. Ko, there's
This
a
is being recorded.
restriction that tells you, am I a passenger on the Pokemon Go?
And
it
guess
makes
what?
it so
I'm
you
always a
can't-
passenger. I'm a passenger in the
So it
driver's
makes
seat.
it so you can't hatch the eggs, Mr. Ko.
Really?
Yeah, if you go too fast, it sends that you're in a
Oh,
car
yeah.
and doesn't hatch the
That's
eggs.
why I am driving at 10 miles an hour on a 35-mile road. I'm going to just skip this to 12, okay? Negative 2x to negative 3 plus 2x to negative 2. Okay. All right. That's it. Okay. Just don't forget the negatives like Mr. Ko.
You can simplify the first one too.
Yeah, you can simplify it. You can simplify these two. Yep. Okay. So not supposed to be hard, but you guys just gotta be able to get it done. Okay, this is a fancy question. Rocks are falling from the nearest blah 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 surface, blah blah blah, distance covered, blah blah blah. All this is blah blah blah, okay? Now the only important part I see here is our s squared. S is equal to 5.2 t squared. And s is the distance in meters, and t is the elapsed time in seconds. And they told us, find the first derivative, find the second derivative. So how to get from s to ds? Take the derivative. ds over dt is equal to 10.4 t dt over dt, and that cancels out, right? The derivative of t is dt, and that's 1. We take the second derivative, ds squared, d squared s over dt squared is equal to 10.4. Okay, let's move on to the next question. All right, so this one is going to be quotient rule. So we take the quotient rule of that. I know some people were still struggling with quotient rule. So let's go ahead and go through the problem. Now the quotient rule, remember, is a very simple trick. Derivative, if I call this f over g, we take the derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, over the bottom squared. And it really is, if you're getting this wrong, it's you're overthinking. You're using too much brain power. Too much brain power, so stop it. So the derivative of the top is just cosine of x, right? Derivative of cosine, sine is cosine, and leave the bottom alone. So we just copy the bottom. Minus the derivative of the bottom, derivative of 1 is 0, derivative of cosine is back to cosine. Leave the top alone, over, copy the bottom squared. And you'll notice some stuff is going to cancel out here. Easy peasy. How can you get this wrong? Okay, this is going to find the second derivative. So this one was a little more tricky. It wants to find the second derivative. So first derivative, y is equal to 2 secant of x. Y prime is equal to 2 secant tangent, excuse me. Right, derivative of secant is secant tangent. Uh-oh. I had someone say something in the chat. Yes, it doesn't require to simplify. Yeah, please, save yourself some time. Second derivative is, that's a product rule now. That's a product, right? So 2, if I write the parentheses, is secant, derivative of secant is secant tangent. And then times tangent. And then multiply it, so plus the back, which is secant squared, and then secant. Okay, because it's the derivative of tangent is secant squared, and we just copy secant. Okay, and that's how they end up with secant cubed. Yes, you still don't have to simplify for MyLab Math.
What's the last one?
What mean last what? In that last problem?
In your work, what was the last?
Oh, it was back to secant x.
Secant x?
Yeah,
Okay.
because we copy the front.
So then you could just write out this whole thing and be correct? Or you could simplify?
Yeah, if you want to. But if you simplify, you probably save a little bit of time of typing.
Okay.
Just a little bit of time typing. You find the derivative of dy dx. No, what? I think you guys are kind of okay with this first page, right? Let's go ahead. I want to jump to the second page. That's probably where you guys need a little more help. Okay, 13 questions. All right. So let's take a look. Use the derivative of the function of f of x and find the points at which f has a local min and local max or point of inflection. Local min, local max. C. Okay, they're different parts here, okay? So I'm going to go ahead and show the answers so they give us all the questions, so I'm writing it out. Okay, so here's the first trick part of this. I gave you that this is not y, this is the derivative already, y prime. So I did the work for you. To find mins and maxes, we make this equal to 0 because we're looking for critical points. We have a critical point when x equals to positive 2, and when x equals to 3. These are my critical points. I'm going to draw my little chart here at 2 and 3. Now I need to figure out which one is my max and mins. The first question is A, B, at what values does x have a local maximum occur, okay? So we need to plug in our signs. So careful, there's a negative here. Everyone see that as negative? So if I plug in something that's bigger than 3, let's do bigger than 3 first. That's going to be positive, positive, negative. Unfortunately, that's going to be negative. A number between 2 and 3, that's say 2.5. 2.5, this is negative. This is positive, but we're still negative. This is going to be now positive. A number less than 2, that's a 0. That's going to be negative, negative, and still negative. That's going to be negative. So we have a down 0 up. That is a minimum. Up 0 down, that's going to be a max. We have a maximum at 3. That's how fast you got to do these questions. I don't know what the maximum value is. Hell if I know. All I know is that we have a max there. Follow-up question is, do we have any point of inflections? Now to find the point of inflection, remember that's the next derivative. So we have to actually take the derivative of this again. So I'm going to actually take the derivative as we see it. X minus 2 squared x minus 3. We could multiply it out if you wanted to. That is totally a possibility. But I'm just going to take the derivative using product rule. So negative in the front. We're going to say 2x minus 2 to 1 power times 1. Chain rule. Leave the back alone. Plus the derivative of the back is just 1. And then x minus 2 squared. Okay. I'm going to go and simplify this. The way I'm going to simplify is I'm going to see that we both have x minus 2 in the front. I'm going to take that out. So negative x minus 2. What's left over? We have a 2 times x minus 3. That's left over. And plus 1. So we're left with 2 times x is 2x. That's a negative 6 plus 1 is negative 5. Is that right? Or I messed up here. Oh, I might have messed up in the math.
You didn't leave one of the x minus 2 because it's
Oh,
squared.
thank you. Yeah. Thank you. That's what the catch was. I was thinking I was missing something. That's going to be 8, and that's going to be a 3. That makes more sense. So this is my second derivative, or let's call it y prime since they have it already. Y prime, double prime. All right, so what are the zeros for this problem? The zeros are 2 and 8 over 3.
Wait, Mr. Ko, could you go over where you messed up? I'm kind of confused
Okay,
now.
sorry. I, instead of multiplying all this out, which you could have done right here, you can multiply it all out. I just said, hey, I have an x minus 2 and x minus 2 that I factored out. Now remember, there's 2 of these. So we had to leave 1 behind. So when you do the math, it's going to be 2x minus 6 plus x minus 2. So it's 3x minus 8. Okay, and if you want to go and test this, if I plug in, here is 2, and this is 8 over 3. A bigger number than 8 over 3, that will be super positive. That's positive. That's going to be negative. If I plug a number between 2 and 8 over 3, so this is going to be positive, but this is going to be negative. So it's going to be positive, and this is going to be negative. Okay. So these do change concavity. Yes, Jacob?
So after this, or when we're doing this, we already have the derivative of the first equation. So then we find the maxima through that, and then we take the derivative, the second derivative.
To find concavity, because the point of inflection is in the second derivative.
So how'd you get 3x plus 8? And
okay.
I'm confused on how you got the
right
second
here,
derivative.
you could multiply this all out and then look for things. But the trick is, I have common factors. I have a common factor of x minus 2 and x minus 2 here. Okay, with that part, that's why I factored out x minus 2.
Okay.
What's left is a 2 here and a x minus 3. Multiplied out to be 2x minus 6. On the back side, this is what I think Ryan pointed out, that this was squared, right? So if I took out 1, I still had 1 left.
Oh, but okay, if you had multiplied all that out, though, you would have gotten
some huge polynomial, which then I would still have to factor.
And then you would simplify and then find the derivative, and that would be okay.
Oh, we wouldn't find the derivative. We would find the zeros. So the trick is,
that's what I
if
meant.
I could take out the factors first, then there's less for me to do.
Oh, okay. I think I lost you there.
It's okay. No, that's good. If you lost me, probably like 80% of the class lost me. Can we cue Luigi? Okay. He's not gonna cue it. He's not gonna
Oh my god!
There you go.
Sorry, I
Thank
had to
you.
pull it up.
It's okay. No worries. Yeah. I caught you off guard there.
Yeah. And keep it like right on top of the screen. I'm not even gonna write down notes. Finger on the button right now.
Please.
You know what? I'm gonna put a keybind to it.
No, don't do it. Don't waste your time. I was messing with you.
I already
100%. Oh my gosh, I was 100% messing around. Okay, so the next part, one of these are related rates questions again. Find the smallest. Oh, this is maximizing. Okay, find the smallest perimeter of the dimensions of the rectangle with the area of 4 inches squared. So the area is 4 inches squared. That we know that already. Okay. And we want to maximize something, means we take the derivative of that equation, okay? So What's the equation? It's a rectangle. So we know, let me draw this out so you guys can see it. The rectangle is length times width. So the area is length times width. Okay. Find the smallest. Oh, sorry, I misread that. They didn't want the smallest area. They want the smallest perimeter. Okay, smallest perimeter. So perimeter equation is 2w plus 2l. In this case, in this picture, if you see something, let's say next to a river, or that's like a river, the perimeter changes because let's say this is length and width. That's 2w plus l. So the situation changes depending on the shape. So when they say smallest, that means I need to take the derivative of this guy. So the derivative of this guy is, let's see, how are we going to do this? First thing, I don't want two variables if I don't have to. We know that our area is going to become 4. So that's not going to change. So we can plug that in. So we'll say we're going to swap one of these variables out. So you pick, do you guys want to get rid of L or W? Doesn't matter, right? So if I say 4 is equal to L times W, W is equal to 4 over L. Let's choose that. Okay, sacrificial lamb. And the goal is we don't want two variables. So P is equal to 2W plus, that's a 4. That's going to be 8 over L. Oh, 8 over, darn it, I substituted the wrong one. Oh my goodness, what's wrong with me? Just talking. 4 over L plus 2L, where P is equal to 8 over L plus 2L. Okay. Now we take the derivative here, so we'll call that P prime is equal to the derivative of find the smallest perimeter. Okay. And then we're going to take the derivative of this. It's going to be, let's see, 8 L to negative 1. So that's going to be negative 8 L to negative 2 plus 2. The derivative of L, we'll just say it's going to be 0 is equal to, sorry, L is 1. And that's going to become 0. Okay, we're going to rewrite this. That's negative 8 over L squared plus 2 common denominator, we need L squared here. So when does negative 8 plus 2L squared over L squared equals to 0? Now the trick is, for fractions, you only care that the top goes to 0. You only care about the top going to 0. So negative 8.
Mr. Ko, where'd the 2 or the L squared come from after the 2?
Oh, right here, I need a common denominator. So this is on the bottom. So in order to add these together to get one big fraction, you have to give ourselves an L squared to both of them. There's no way for me to put this. So we make the top go to 0. So making the top go to 0, we add 8 to both sides. 2L squared is equal to 8 divided by 2 divided by 2. L is equal to plus or minus the square root of 4. That means L can be only positive 2. So we know what the length is. That's 2 and 2, right? 2 and 2. What's the area? We know the area is 4. So right here, 4 equals to 2 times W. W has to be 2 then. 2 times 2. So what is the smallest perimeter? The smallest perimeter is 2 plus 2 plus 2 plus 2. P is equal to 8. What are the dimensions of the rectangle? The dimensions are 2 by 2. So here's the part that's usually the part that gets us a little confused. Once we reach our equation that we're going to optimize, we take a derivative like this was just x. Like if that was just x, to make it easy for us. Okay. So this isn't rate. We're not doing it dl dt. This is just what's the derivative of L? That's L prime. L prime is going to be 1 for us. Or what's the derivative of X? Just 1. Okay, we're running out of time. I'm going to do one more quick question here, and then we'll call it. And if you guys get stuck on these, please let me know. I'll do a video on it, okay? Do one more question. Okay, if you guys gotta go, you guys gotta go, okay? That's not a problem. And then I'll post this once it's done rendering, okay? The regular plot of a farmland would be bounded by one side by a river, okay? We talked about the river problem. And electric fence. There is 1,100 wires of this at your disposal. What is the largest area you can enclose? So we're gonna maximize our area, so maximize the area. And area in this case is going to be length times width. What?
Have a nice day, Mr.
Yeah, you too. See ya.
Oh my god!
Oh my god. Is equal to 2 L's plus W. That's to say this is L, L, and W. Add those together. And this is going to be 1, 1, 0, 0. So that's constant. 2 L's plus W. Now our goal is to maximize this, so we know we're taking the derivative of this, but we don't want to use too many variables, remember? So the trick is I'm going to go ahead and solve W is equal to 1100 minus 2L. So we plug it in. L is 1100 minus 2L's. That's my area. And then I want to multiply this out to make my life a little easier. It's going to be negative 2L squared plus 1100L. And we're just going to take the derivative. A prime is equal to negative 4L plus 110. Make this equal to 0. Looking for critical points. In this case, it's actually not that difficult. The critical point is going to be negative divided by 4. L is equal to 1100 over 4. Half of 110 is 550. Half of 550 is 225. Is it 225? 275. Whoops. 275. That's the length. 275, 275. The last part has to be double, so that's going to be 550. Okay, so we know the dimensions. So the maximum area is we multiply them together. That's the maximum area, and the dimensions are our sides. Okay, if you're not sure how to get W, we can go back here and plug 1100 minus 2 times 225. We said we know what 275, and that gives us our W, which is 550. Okay, so the problem's going to be actually pretty quick once you know exactly what to do. Okay, thank you very much, guys.
Mr. Ko.
See you guys. Have a great weekend.
Thank you, Mr. Ko.
Email me if you guys need
See you
help.
on
Okay?
Tuesday.
Thank you.
Bye.